Okay, YouTube, this is my third video in which we're using sum and difference formulas, in which we're going to confront using a tangent formula for the sum and difference formulas, which we haven't done yet, as well as we're going to continue to simplify an expression, which is a useful thing to know how to do, of course, when you're proving, say, trig identities or verifying them. So let's go ahead and visit our tangent sum and difference formula here. We say that the tangent of the sum or difference of two different angles, u and v, would be equal to this. Now you'll notice that we have a sum on top here between our two tangent values. We have tangent u plus or minus tangent v. So the first thing I'll note here is this. Because this is plus or minus, it means that it's going to match this sign over here in this sum or difference, okay? And in the bottom we always have 1 minus plus the product of these two tangent values of the two angle parts, okay? So this minus plus is going to indicate that it is opposite of what the initial, sum or difference was over here. So if this is a sum, this will be a difference, and vice versa. And there's always a 1 with the product of these two things down here, tangent u, tangent v. Okay, so this is, I don't know, it looks more intimidating than it really is, but we have the sum of the two, tangent angle parts up top over, 1, minus plus the product of those two things, those two parts. So I've listed this over here. Let's go ahead and take the time to simplify this expression. So the very first thing we want to do is we want to identify what our u and v are. And we identify here that our u, in this particular instance, is just a general angle theta, and our v is this angle 3 pi. Okay, so now what we're going to do is we're going to use our sum and difference formula to rewrite this, and so I will do that. We're going to go ahead and write a big quotient here. And we'll just write in our parts and then fill in the angles afterwards. But because this was a sum here, I know that on the top here I have the sum of two tangent values, and on the bottom I have 1. Now this would be a minus, and when we say tangent u times the tangent v, the product of the tangents of these two angle parts here. So we're going to go ahead and fill in our u's and v's, but we say our u in this particular case was theta, so we say u on top and bottom, and then we say on top we have 3 pi. So as far as simplifying this goes, of course, it's very helpful to know your unit circle. That is to say, our unit circle is a circle of radius 1 centered at the origin. And to say we have a 3 pi radian rotation, well, there's 1 pi, 2 pi, 3 pi. We say, what are the tangent values here? Okay, so we're going to need to know, and we say that this point -1, 0 corresponds to this outer part. Now, let's say you have your unit circle available to you. I'm just saying, you wouldn't have to draw it yourself, but we say, 3 pi is located here. We're going to need to know the tangent value of 3 pi, and so the tangent value is going to be this y value divided by this x value, or 0 over -1, which is 0. So what we could say is anywhere we see this tangent of 3 pi, it is fair to say that that is going to become a 0. So I'm going to rewrite this entire expression because I believe that it'll be helpful in visualizing this a little bit here. But we say tangent theta plus, in this particular case, a value of 0 over 1 minus the tangent of theta times a value of 0. So what this means is that'll cancel out, and this is something we can neglect, okay? And so what we end up getting is just the tangent of theta. So that is to say that an expression that we started with here, the expression tangent of theta plus 3 pi, could be simplified to be written as the tangent of just theta. Cheers.